let us continue. We now talk about American options. What are American options? American options are options that have the special right, a special privilege that they may be accessed at any point up to the date of maturity of the option. In contrast to European options, which can be accessed only on the exercise date, American options can be accessed at any point during the life of the option. There is a very interesting paradox to start with when we talk about American options. If you have an American call on a non-dividend paying stock, it is never optimal to early exercise, rather to early exercise the American option. In other words, it is never justified, it is never justified on rational considerations that you early exercise the American call on a non-dividend paying stock. That is, you do not, or you should not, at least it is not optimal that you exercise the American call prior to its maturity on an underlying which does not entail any dividend payout during the life of the option. This is very interesting. Let us take it up. Suppose you hold an American call on a stock, and please note, whenever we use this stock, we are talking about a non-dividend paying stock for the purposes of this article. So, suppose you hold an American call on a stock and decide to exercise it at t equal to tau, where tau lies between 0 and capital T. That is, you are exercising it prior to maturity. You are exercising the option prior to maturity at any let tau be any arbitrary point in time between 0 and capital T. You will do so only if S tau is greater than k, because if S tau is less than k, you will not get any payoff from the option. There is no point in exercising the option. There is no rationality behind exercising the option if S tau is less than k. If S tau is greater than k, what will you do? You will exercise the option, you will buy the asset at k, and you will sell it in the market at S tau, and you will make a profit of S tau minus k. Of course, for the moment ignoring the premium on the option. Then you will get the underlying stock immediately and at a predetermined price k, and obviously you can, if you choose, if you want, you can sell the underlying asset, as I mentioned just now, at S tau and make a profit of S tau minus k, make an instantaneous profit of S tau minus k, or you can also hold on to this stock up to the date of maturity of the option. There are two possibilities, in fact. Number one, you decide to hold on to the stock after exercising the option at t equal to tau up to t equal to capital T, that is the date of maturity of the option, or you buy the or you exercise the option at t equal to tau, and within the period tau to capital T, you decide to dispose of the stock at the then prevailing market price. We will examine each of these two options separately. Let us look at the first option. The first option is you decide to hold the underlying asset, you decide to hold the stock yourself up to option maturity, up to date t equal to tau. Let me repeat what has happened. You have exercised the option at t equal to tau, where tau is some intermediate point between 0 and capital T. In other words, you have early exercised the option, American option, and after exercising the option, which would imply that you buy the stock, you receive the stock, and you keep it with you up to t equal to capital T, and you make the payment for the stock at t equal to tau for the exercise price. So, let us assume that you hold the stock up to t equal to capital T. Now, the argument must be understood very carefully, that now if you have exercised the option at t equal to tau, what is your holding at t equal to capital T? Say this is 0, this is somewhere here is, let us say, tau, and here is capital T. Now, at this point you have exercised the option. So, what has happened? You have paid the cash equal to k, and you have received the stock. So, at this point, when you reach this point, what is your holding in this portfolio? Your holding is only equal to the stock, and the stock will be worth what? The stock will be worth ST. Okay. And please note, you have made the payment at t equal to tau. Now, the argument is that suppose you do not exercise the option, then what happens? Then as on this state t equal to capital T, your holding is what? Your holding is an option, call option, that is American call on the same stock. Now, at this point t equal to capital T, what happens if you exercise the option? If you exercise the option at t equal to capital T, that is the maturity of the option, not early exercise, then what happens? Then you get a stock which is worth ST and you pay the price which is K. So, this is an outflow, this is an inflow. Now, please note one very obvious factor. In the first strategy, when you had early exercised the option, you had paid the price at t equal to tau. In the second case, when you have not early exercised the option, when you have exercised the option at maturity, you have paid the price at t equal to capital T. Obviously, capital T is after tau, tau is here, capital T is here. That means, by early exercising, you have made the payment earlier, and because you have made the payment earlier, you lose interest for the period from t equal to tau to t equal to capital T on the amount of exercise price. This is one fundamental drawback, one fundamental issue against the early exercise of the option. Now, the second point is even more intriguing. When you reach this point t equal to capital T and you still have the option with you, and suppose the stock price plummets down, stock price goes down rapidly, is in a downswing and is well below K, then you can always think about, you can always use the discretion not to exercise the option. If at the last minute you feel that you have made a mistake, you do not want to hold this stock, you can always let the option lapse, and by letting the option lapse, your loss is confined to the amount of premium that you have paid on the option. Because you have not bought the stock, the loss on the stock is not to your account. Only the amount of premium that you have incurred for buying the option is the loss that you would encounter if the stock price goes down and you decide not to invest in the stock. On the other hand, if you have already exercised the option, the stock is already with you, and if the stock price goes down significantly, the entire loss is to your account because you are the owner of the stock. In the second case, you are the owner of the option, not the stock. So, you can get out of it, you can review, you can revisit your decision to invest in the stock. Okay, the stock is going down, let us avoid investing in it, and in that case, if you let the option lapse, the only cost that you incur is the amount of premium that you have paid. So, this is the protection, this is a kind of insurance against the stock fall. If there is a massive stock fall, then you are better placed if you have not exercised the option, because the loss on the stock will not be to your count, you have not bought the stock as yet, and if you have that right in that case to revisit the decision to invest in the stock, let the option lapse and get away with a loss equal to the amount of premium. This is not available if you have already exercised the option at t equal to tau, because you have the stock with you, the option is gone. You have the stock with you, and whatever price fall occurs in the stock is to your account. So, these are two fundamental reasons which motivate or which mandate that early exercise of American calls on a non-dividend paying stock is never optimal. Let me repeat, early exercise of American calls on non-dividend paying stocks is never optimal. Number one, the issue of early payment of exercise price. Number two, insurance against fall in the stock price, enabling you to revisit the decision of investing in the stock. Now, let us look at the second situation. Second situation is, if you sell the underlying asset between tau and capital T, you have exercised the option, you have, what happens? This is, let me draw the timeline, 0, tau and capital T. So, at this point you have exercised the option, you have paid K, you have bought stock, and within this period tau and capital T, tau comma capital T, at any point you sell the stock, You sell this stock and you receive S theta, let us call it, where theta is any point between theta is contained in tau and t, any arbitrary point between tau and t. Now, let us compare the two situations from the perspective, not of your perspective, from the perspective of the person who is going to buy the stock at t equal to theta. The question is, would he be better off buying the stock at t equal to theta, or would he be better off buying the option unexercised at t equal to theta? That is the big question. Now, let me repeat, buying the stock, you have exercised the option, the stock is with you, and Mr. X buys the stock from you at t equal to theta for the price S theta. That is one possibility. The second is, we compare this possibility with the second one, which is that you sell the option unexercised, option not exercised, to somebody, to let us say to Mr. X at a certain price. The question is, which is better from the perspective of X. Let us assume that it is now X who will hold the stock up to maturity. Then what happens? Then the holding of X becomes worth S capital T, because he has bought the stock from you as at theta, and he is holding up the stock, and his holding is worth now S capital T. And if he buys the option from you, he keeps the option with him, and as on the date of maturity, that is S capital T, he decides to exercise the option, then again he has one stock with him which is worth S capital T. So, as far as he is concerned, the stock that he will be holding, or the portfolio that he will be holding, whether he buys the stock at t equal to theta or buys the option at t equal to theta and exercises that option at t equal to capital T, will be equal to S t. But again, as in the previous case, Mr. X will have that opportunity that if the stock goes down, if the stock goes rapidly, plummets, then he could get out of the investment in the stock, because he has not bought the stock, he has not exercised the option. So, because of that prerogative, that additional benefit, that additional insurance, that additional protection against a fall in price, and the right to revisit his decision whether to invest in the stock, he would be happier that he has got the option and he has not invested in the stock at t equal to theta. And therefore, when he buys the option unexercised, he would be paying willing to pay a higher price than the price of buying the stock less the exercise price. In other words, the payoff, if the option is exercised at t equal to theta, the payoff is S theta minus k, but if the option is unexercised, the payoff would be slightly higher. You would be able to sell the option at a slightly higher price. So, there again you find that if you do not decide to hold the stock to maturity, and somebody else decides to hold the stock to maturity, howsoever long this chain may be, somebody would be there who would be willing to hold the stock to maturity, because otherwise the stock price would not be sustained. Somebody has to be there who is willing to hold the stock to maturity. This process or this derivation would hold in the context of that person as well, and as a result of which it would not be optimal that he buys this stock after you exercise the option. He would be better off buying the option instead. Okay. There is a quantitative argument in favor of this as well. We have already established that the lower bound of a European call is given by equation number 1. We have already established that the lower bound of a European call, small c means European call, is given by equation number 1. Also, we know that because the American call gives you a certain additional right over whatever you can do in the context of the European call. So, therefore, the price or the value of the American call must be greater than, at worst case it should be equal to that of the European call. European call can be exercised only at maturity. American call can be exercised any time up to maturity. So, whatever the European call holder can do, American call holder can also do. So, obviously, the price of the American call has to be either greater than, and in the worst case scenario, equal to the price of the European call. So, that means this. Therefore, the American call's lower bound is also given by this expression. This is equation number 2. Because capital C is greater than equal to small c, the lower bound for small c must also be a lower bound for capital C, and that is precisely what this is saying. Since r is greater than 0, what is r? R is the risk free rate, and r is used in practical circumstances, r would be greater than 0. If r is greater than 0, this implies that c is greater than s tau minus k, because the right hand side, this expression, where if r is greater than 0, obviously the present value of k is less than the actual value of k, and therefore, this is the present value of k, this is the present value of k, and when we are deducting present value of k from s tau, I will get a larger number compared to when we are deducting k from s tau. Why? Because present value of k is smaller than the value of k. Therefore, c has to be greater than, now please note equal to is missing, s tau minus k. What is s tau minus k? S tau minus k is the instantaneous profit, instantaneous payoff that you derive from exercising the American call. If you exercise the American call at any arbitrary point in time between say t equal to 0 and t equal to capital T, let us say t equal to tau, the profit that you make, you buy the asset at k and sell it in the market at s tau, the instantaneous profit or the instantaneous payoff, the rather, if you ignore the price of the call, is s tau minus k. That means what? That means if you immediately exercise the option, you get a profit of s tau minus k, and if you sell the option, the worst case scenario, even in the worst case scenario, you get something better than s tau minus k. That is precisely what I explained a few minutes back in a descriptive manner. So, what is C? C is the price that you get if you sell the option unexercised. What is s tau minus k? S tau minus k is what you get if you exercise the option and then sell the stock, that is s tau minus k. You exercise the option, buy the stock at k, sell it in the market, you get s tau minus k. You sell the option without exercise, you get capital C, and we know that C capital is greater than s tau minus k. That immediately implies that it is not optimal to early exercise an American call on a non-dividend paying stock. Early exercise of American puts. This is even more interesting. What is a put option? A put option is a right to sell, and what is an American put? An American put is a right to sell the underlying asset at any point between 0 and capital T, where capital T is the maturity of the option. Consider an American put option with exercise price k and maturity capital T. We need to establish the existence of at least one scenario, because we are trying to contradict the argument, the contention that early exercise of American put is also not optimal. Is it true? If it is true, it has to be true for all scenarios. If we can identify, or even if we can identify one scenario in which it is not true, then the statement breaks down. The statement that early exercise of American puts is not optimal breaks down if we can identify even one single scenario in which it is optimal to early exercise in which it is optimal to early exercise the American put. If you can establish one scenario in which it is optimal to exercise the American put, the contention, the argument, the statement that early exercise of American puts is not optimal will break down. That is what we will try to do. We need to establish the existence of at least one scenario such that it would be optimal to exercise the American put. It would be optimal. Please note this fundamental thing. What we are trying to do is, we are trying to contradict the statement that it is never optimal by identifying a situation where it may be optimal. To understand this, recall that a put option provides protection against a price fall. That is, if the asset price falls below the exercise price, the put option holder can sell the asset at the exercise price. That is what is the characteristic of a put option. Hence, consider a situation, say at time t equal to tau, where 0 less than tau less than t, that is tau is some intermediate point between 0 and capital T, at which the price of the underlying asset is almost 0. Price of the underlying asset is almost 0. In this situation, why would you hold on to the American put? Only why would you hold? You see, the temptation is that you exercise the option, get the exercise price and deliver the asset, and lower the price of the asset, lower the market price of the asset, greater is the benefit to you, greater is the temptation that you exercise the put, because the put will give you the right to sell the asset at a higher price relative to what the market, and the market price for the moment we are assuming is very low. So, the question is, why would you not exercise the put option? Obviously, you will not exercise the put option in only one circumstance, that is, you expect the price of the underlying asset to fall even further, because if the price of the underlying asset falls even further, then what happens? Then your price, your profit increases, your payoff increases. What is the payoff? The payoff is given by k minus s tau at any point in time t equal to tau, if s tau is less than k, k is greater than s tau. Now, the lesser the value of s tau, the closer s tau is to 0, the smaller s tau is, the greater is this profit. So, if you are not selling the, if you are not exercising the put option at a given point in time as tau, if you are holding on to it for the remaining period tau to capital T, you would only do so if you have a perception that the stock price could fall further, and therefore, at that point in time when the stock price falls further, you exercise the option and you get a greater profit k minus s theta, let us say, where s theta is less than s tau. But the question is, if the stock price at tau is already very small, negligible, very small, then what is the probability that it would go even below, more less, or would fall down further? The probability is very low. So, the rationale or the motivation to hold on to the option decreases when the price is already very low, massively low, almost close to 0. The temptation is to exercise the option. The rational strategy would be to exercise the option rather than waiting further, because waiting further is unlikely to result in further decline in price if the price already at tau is very low. So, that means what? That means it is better that you exercise the option at t equal to tau. Then there is an added advantage. Contrast the situation with the situation that we encountered in the case of American call. The American call was a right to buy. So, you were paying the cash, you were paying the exercise price, here it is a right to sell. So, you are receiving the cash. The earlier you receive the cash, the better it is. You can reinvest the cash into some other profitable adventure. And that means what? That means the earlier you exercise the put option, the better it is. So, that is the rationale, that if the stock price is small enough, the stock price is low enough, there would be little motivation to not exercise the option, and it may be true that the exercise of the American put at this earlier point in time be optimal, because at the end of the day you are getting the exercise price, you can reinvest the exercise price. The later you exercise the option, the later is a receipt of the exercise price, and the later is your investment, the loss and the consequential loss of interest. Now, put call parity for American options. It is not a parity relationship, please note this. It is something similar to a parity relationship. It is not an equality relationship, but let us do it. The process is pretty much identical to what we had in the case of European options. We have portfolio A, we have a European call here, we shall be talking about it later on, that for the moment European call, and because the Americanness manifests itself as a right to exercise the option at any point between 0 and capital T. Let that arbitrary time be termed as tau, be called tau, and then we also have to consider the payoffs at t equal to tau. So, this is an intermediate time t equal to tau, and then we have the maturity at t equal to capital T as usual. As far as the European call is concerned, it will not be exercised at any point earlier, but it may have a non-zero value. Please note that at t equal to tau, it may have a non-zero value, but invariably a non-negative value. Obviously, a call option cannot have a negative value. A long position in a call option can never have a negative value. Why is that? Because it is a right. A right cannot have a negative value. So, because it is a right, what happens that the value of the European call is either 0, at the worst case scenario it is 0, but it would be greater than 0, or worst case scenario 0. And if S t is less than k, the payoff is 0. If S t is greater than k, the payoff is S t minus k. And we invest now. Please note, in the case of the earlier put call parity, we were investing present value of k. Here we are investing k. Please note this difference. So, because you are investing k at t equal to tau, the value of this investment will be k e to the power r tau, where r is the relevant rate, and at t equal to capital T, the investment would be worth k e to the power r t. And please note, this k e to the power r t is independent of the state of the stock price, whether it is less than k or it is greater than k, right. So, this is as far as portfolio A is concerned. The cash outflow at t equal to 0 is equal to c plus k. The value of the portfolio at t equal to tau is greater than or equal to, depending on the value of the call. If the value of the call is 0, the value of the portfolio is k e to the power r tau, and if it is greater than 0, the value of the portfolio is greater than k e to the power r tau. And as far as t equal to capital T is concerned, if S t is less than k, the portfolio is worth k e to the power r t, and if S t is greater than k, the portfolio is worth S t plus k e to the power r t minus k. Now, please note this part is greater than 0. So, this whole thing is greater than S t. Now, we will look at portfolio B. Portfolio B, we buy 1 unit of the stock, costs us S 0, its value at t equal to tau is S tau, its value at t equal to capital T is S t, and S t is obviously whether S t is less than k or greater than k, it does not matter, it will always remain S t. American put, the price that you pay is capital P, please note this, so it is minus capital P. Now, at t equal to tau, you will obviously exercise it only if S t is less than, if S tau is less than k, if S tau is greater than k, there is no point in exercising the American put, you will not get any payoff. So, if S tau is less than k, the payoff will be equal to k minus S tau, and in the event that you hold on to the American put up to maturity, you get k minus S t, if S t is less than k, 0 otherwise. The total payoff in this case is at t equal to tau, it is k, at t equal to capital T, S t less than k, it is k, at t equal to capital T, S t greater than k, it is S t. You compare these payoffs, let us call these payoffs A, let us call this payoffs B. You compare payoffs A and B, what you find is that in each case t equal to tau, t equal to capital T, S t less than k, t equal to capital T, S t greater than k, portfolio A outperforms portfolio B. The payoffs of A are higher than portfolio B payoffs at every point, or because tau is an arbitrary point, please note this, we have not identified any specific tau, it is any point between 0 and capital T. So, the payoff at any arbitrary intermediate point for portfolio A is greater than B, and the portfolio at the payoff at maturity of portfolio A is also greater than that of portfolio B, or worst case scenario it can be equal when r is equal to 0. The theoretical possibility of r being 0 means that in that situation when r is equal to 0, the payoffs at maturity of the two portfolios can be identical. So, that gives us this, that means what? That means the cost of cost of setting up the portfolio A has to be greater than the cost of setting up of portfolio B, and that gives us this relationship. And now because of the early exercise issue, because early exercise of American calls is never optimal, we get small c is equal to capital C or capital C is equal to small c. You may look at it either way, but why it is so? Because capital C, that is the Americanness, does not result in any incremental advantage, because it is never optimal to use this Americanness property. It is never optimal to early exercise the American option, and that is the Americanness property. In other words, because it is not optimal, it is not worth anything, and therefore small capital C will be equal to small c. Substituting capital C for small c, what we get is expression number C, which is one part of the put call parity for American options. Let us look at the other side. Now, from the previous slide, what we have is S0 minus K is less than C minus P. Now, from put call parity for European options, we have this equation number 1. This is straightforward. Rearranging this equation number 1, we get equation number 2. Now, this small c can be replaced by capital C for the reason I mentioned just now, but because early exercise of American puts may be optimal in extreme situations, we must have small p is less than capital P, or less than equal to rather in capital P. Worst case scenario, it can be equal. So, small k p is less than equal to capital P. Why? Because there may exist situations where the early exercise gives you a certain value addition. You can early exercise and with optimality, and therefore small p is less than equal to capital P, and therefore it means capital C minus capital P. You see, look at equation number 2. From equation number 2 we get equation number 3. This is equation number 3. You see, small c and capital C are same. Small p is smaller than capital P, they are smaller or equal to, that is. Therefore, capital C minus capital P must be smaller than or equal to small c minus small p, and therefore capital C minus capital P, using equation number 2 now, capital C minus capital P must be less than equal to S0 minus k e to the power minus RT, present value of k. Therefore, combining the equation that we derived in the previous slide and this equation number 4, we get equation number 5, which represents the equivalence of put call parity for American options. We will continue from here. Thank you.